Today we're learning how programs make decisions. Without if-else statements, your code just runs top to bottom. With them, your programs become intelligent. We'll explore Boolean logic, true and false, and or not, the building blocks of all decision-making in code. And I'll show you how to write conditions that actually make sense when you read them 6 months later. This matters more than you think. Up until now, our programs have been pretty dumb. They do the same thing every time. But real programs need to react to data, make choices, handle different scenarios. That's where if-else comes in. It's literally how we teach computers to make decisions. Okay, so here's what's happening if checks a condition. If it's true, the code in the curly braces runs. If it's false, it skips right over it. Double equals checks if things are equal. Exclamation equals checks if they're not equal. Don't confuse char with single r for assignment. Less than, greater than, and their or equal to variants. These work exactly like math class. Double ampersand means and, both must be true. Double pipe means or, either can be true. Exclamation means not. The is keyword checks types as tries to cast, and double question mark handles nulls. We'll cover these later. With else, you're saying if this is true, do this, otherwise do that. Exactly one of these blocks will run. Never both, never neither. Else if lets you check multiple conditions in order, it stops at the first true condition. Order matters here, and put most specific conditions first. Don't nest if statements when you can combine conditions. Use and for and, yeah for or. And please, never write yeah true for booleans. They're already true or false. The ternary operator is like a compact if-else for assigning values. Question mark means then, colon means else. Perfect for simple assignments. When you're checking one variable against multiple exact values, switch is cleaner than a bunch of if-else statements. Don't forget the break statements. With and, both conditions must be true for the result to be true. Think of it like this and that must both happen. True and true equals true. This is the only combination that works with and. True and false, false, false and true, false, false and false, also false. With or, at least one condition must be true. Think this or that, doesn't matter which. False or false equals false. This is the only combination that fails with or. True or false, true. False or true, true, true or true, also true. Always check for null before using reference types. That question mark operator is super handy. It only accesses the property if the object isn't null. Modern C# has pattern matching that makes conditions even cleaner. The is keyword can check type and assign in one step. Switch expressions are super concise. This drives me crazy. Single equals is assignment, double equals is comparison. If x or 5 won't even compile in C#, thankfully. You can omit braces for single statements, but please don't. It makes bugs so much more likely when you add code later. If you're nesting more than 2-3 levels deep, step back. Extract methods, use early returns, or rethink your logic. Instead of if x 17, write if age, voting age. Your future self will thank you. Pull complex conditions into well-named Boolean variables or methods. If is eligible for discount is way clearer than a bunch of ands and ors. Don't nest unnecessarily, check error conditions first, and return early. This keeps your happy path code at the main indentation level. Instead of if is not valid, write if is valid. Double negatives are confusing. If else statements let your program make decisions and take different paths based on conditions. Use an for and, GIAS for or to combine conditions. Keep them readable. Extract complex logic to methods. When checking one variable against many values, switch is often cleaner than multiple if-else statements. Check for null before using reference types. The and operators make this much cleaner. Next up, we're learning about loops. How to repeat code without writing it multiple times. We'll cover for, while, and for each loops, and I'll show you the common pitfalls like infinite loops. Get ready to make your programs do the repetitive work for you.